Good morning, ladies and gentlemen. How are you going today? So today we're going to look at factorizing non-monic quadratic trinomials. That's a mouthful, so let's write down our title today. We are going to factorize non-monic quadratic trinomials. So this is a follow-on from yesterday's lesson, where yesterday we were looking at factorizing monic quadratic trinomials. So yesterday we looked at how factorizing means writing it as brackety multiplying by each other. Monic meant that the coefficient in front of the x squared is 1. So today when we're looking at non-monic quadratics, the coefficient in front of the x squared is not 1 anymore, but some other number. Quadratic yesterday, as we talked about, was any algebraic expression where the highest power is squared. So if you have anything cubed or higher, then it's not quadratic anymore. Or even if it's just x by itself, that's not quadratic, that's actually called linear. And trinomials, again, are terms with are expressions with only 3 terms in it. So non-monic, as we said, was where the a value, yesterday we said that any trinomial is of the form ax squared plus bx plus c. So a was the coefficient in front of the x squared, b was the coefficient in front of the x, and c is the lonely number by itself. So non-monic is when the a is not equal to 1. So recall from yesterday, we have the form of ax squared plus bx plus c. So the word non-monic means that your a value is not equal to 1, but some other number. So the trick is kind of similar to yesterday, so we have to draw up a table of plus b times ac, but because it's non-monic, the number in front of the x squared is not equal to 1, we have to do an extra 2 lines of working. So the easiest way to demonstrate what these extra 2 lines of working is jumping straight into an example. So let's look at example 1. The verb is to factorize, so we want to write it as brackety multiplying by each other. The thing we want to factorize, the expression we want to factorize is 2x squared plus 7x plus 3. So it's a trinomial because there are 3 terms, 2x squared, 7x, and 3. It's a quadratic because our highest power of x, our variable, is 2. It doesn't go any higher. It's non-monic because the coefficient of x squared, the highest power, is a 2. It's not a 1. And so our goal is to write it as equal to brackety stuff, so that when we expand the brackets, we can get back 2x squared plus 7x plus 3. So like yesterday, we start off with, on the side, as a side calc, write down your a, b, and c values. So a is the coefficient of x squared, the number in front of x squared, which in this case is 2. B is the number in front of your x, which is 7. And c is the lonely number by itself, which in this case is a positive 3. Draw in a little table, a plus b times ac table. Our b value is 7. So in your first column, your b column, you write 7. A and C is 2 and 3, so AC, 2 times 3 becomes 6. So you're thinking of 2 numbers that add to be 7 because it's plus B, and those 2 numbers must also multiply to be 6 because it's times AC. So you're thinking of, what are the factors of 6? Well, 1 and 6 are factors of 6 because 1 and 6 multiply to be 6. 2 and 3 are also factors of 6, because 2 times 3 is 6. Now, between these 2 combos, which combo would add to be 7? Well, 1 and 6 add to be 7. So my numbers of interest in my second row of my table would be 1 and 6. In fact, it will be positive 1 and positive 6, because positive times positive gives you a positive value. and positive 1 plus 6 gives you a positive 7. Okay, so yesterday we would have said, okay, go back to your original problem. We would write equal signs. We would then write brackety, 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 brackety. Now this is where the new trick comes in. Because my quadratic is non-monic, rather than just writing xx like we did yesterday, we would write down instead 2x in this first part of our brackets, because our coefficient is 2. It's 2x squared, so we would write in our brackety parts 2x and 2x. And then we also have to divide this whole thing by that same coefficient 2. So everything's 2 because the coefficient of my x squared is 2. So you have brackety, 2x, and you're dividing by 2. And then like we did yesterday, our two numbers, positive 1 and positive 6, we would fill in to our brackets. So plus 1 and plus 6. Now, when we're trying to factorize, we don't want any of the denominator stuff, so we need to pull out a factor of 2 so that we can cancel out the 2 at the bottom. So have a look at your two brackets. Within the first one, you have 2x plus 1. Are there any common factors? Can you factorize this expression any further? No. Whereas if you look at the second one, 2x plus 6, you can factorize out a common factor of 2 because 2 times x gives you 2x and 2 times 3 gives you 6. So what we can do now is leave the first bracket alone because we can't factorize it. We are multiplying by, we factorized out a 2 out of the second bracket so that whatever's left over is x plus 3. And then we still have to divide by 2, right? And the great thing is, because we have a 2 on top and a 2 on bottom and they're being multiplied, we can cancel them off so that we're left with 2x plus 1 times x plus 3. So there'll be our two factors. We've factorized 2x squared plus 7x plus 3. How do you know you factorized correctly? You might want to do a side check. Just FOIL it first. So 2x times x gives you 2x squared. Outer, so 2x times 3 gives you 6x. Inner, 1 times x gives you 1x, and your last 1 times 3 gives you 3. If you simplify that, do you get what you started off with, which is 2x squared plus 7x plus 3? Yes, you do. So you know you factorized it correctly, because when you expand your brackets, you get back what you started off with, because factorizing is the opposite of expanding. So recapping, if it's non-monic, where the number in front of your x squared is not 1, then you have to do an extra 2 lines of work. So you start off with, on the side, write down your a, b's, and c's. Draw your little plus b times ac table. B is 7, AC 2 times 3 is 6. So you're thinking of two numbers that add to be 7 because it's plus B, and those two same numbers must multiply to become 6 because it's times AC. So think of the factors of 6 of those combinations, which ones add to be 7, 1 and 6, positive 1 and positive 6. So you go back to your question, you go equals brackety, 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 like we did yesterday. Now, because it's non-monic, rather than just writing x inside your brackets, you have to write 2x. Not 2x squared, but just 2x on both of your brackets, because your coefficient of x squared is 2. You also, at the same time, have to divide the whole thing by 2, because, again, the coefficient is 2. Inside your brackets, like we did yesterday, you put your two numbers in, so plus 1, plus 6 into each of the brackets. You then try to factorize out your brackets as much as possible. So you've pulled out a factor of 2 from the second bracket because 2 and 6 have a common factor of 2. Because of this common factor of 2, you can cancel top and bottom with that 2 factor. And then you're left with a brackety expression. And that's what we want. Let's try another one. Let's try B. Let's do 10x squared plus 9x minus 9. So on the side, write your a, b's, and c's as a side calc. A, the number in front of the x squared is 10. So it's clearly non-monic because that A is not 1. B is the number in front of the single x, which is 9. C is the lonely number, which is negative 9. Be careful, don't forget about the negative sign. Take the number, take the sign in front of it. You would then draw your little plus b times AC table on the side. So plus b times AC. Your b value is 9, so in your first column you write 9. AC, 10 and negative 9, they multiply to be negative 90. So you're thinking of two numbers that add, because it's plus, to be 9, and a multiply, because it's times, to be negative 90. What are two numbers that add to be 9 and multiply together to be negative 90? You might need to use a calculator for this one because they're pretty big numbers. And you know for sure that one of the numbers has to be positive and one of the numbers has to be negative. Because to multiply to become a negative, one has to be positive, one has to be negative. If they're both positive, they will not multiply to be negative. And if they're both negative, they won't multiply to be a negative either. So you know that one's positive, one's negative. So you might need to use a calculator and go through, well, what are the factors of 9? I mean, obviously 1 is useless because 1 times 90 is 90, but 1 and 90 do not have a gap of 9. 2 and 45, that still doesn't have a gap of 9. Does 3 go into 90? 3 times 30 is 90, but there's no way 3 and 30 have a gap of 9. Does 4 go into 90? 90 divided by 4, no, it's not a whole number. 5? What about 5? 90 divided by 5 is 18. 5 and 18, they don't have a gap. No matter how you add or subtract 5 and 18, they don't add to become 9. 90, next number is 6. Does 6 go into 90? 6 and 15 using a calculator. Oh, that's promising because 6 and 15 have a gap of 9 between them. So if I could somehow just get the positive and negative signs right, I can have a 9 difference between 15 and 6. So which one do I want to be positive? Which one do I want to be negative? Okay. So I'm thinking that I want the sum to be a positive 9. So if I make 15 negative, then minus 15 plus 6 would give me a negative answer. And I don't want a negative answer as a sum. I want a positive answer. So what that tells me is I should make the 15 the positive one. And then I should make 6 the negative one, because then positive 15 times negative 6 gives me negative 90. 15 minus 6, 15 take away 6, that gives me positive 9, and which is what I want. So they're my two numbers of interest. Go get rid of that. Okay. So back to the question, we write equal signs, bracket, 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 bracket. Because it's 10x squared, I put a 10x and a 10x at the start of my bracket. I also have to divide the whole thing by 10 because the coefficient of x squared is 10, my a is 10. Now inside my bracket, I put in the two numbers I have figured out. One is a positive 15, a plus 15. The other one is negative 6, or taking away 6. Next step, we want to factorize out as much as possible the brackets. So if you're looking at the first bracket, I have 10 and 15. What's the highest common factor between 10x and 15? Well, 5 goes into both of them. So all that's left over is 2x plus 3. And then I'm multiplying by my second factor, which is 10x minus 6. Factorize out the second bracket, 10x minus 6. The highest common factor would be a 2. So it's times 2 outside of 5x minus 3. I'm still dividing by 10. Now this is where you go, I hope I have pulled out enough common factors to be able to divide by 10. Well, if you look at the coefficients, 5 times 2 is 10, and that cancels out with the 10 on the bottom. So 5 times 2 is 10, and that cancels out the 10 at the bottom, which is good because I do not want a denominator. So then my final answer is brackets 2x plus 3 times brackets 5x minus 3. Again, you can always check your answer by expanding your brackets. 2x times 5x gives me 10x squared. Check. 2x times negative 3 gives me a negative 6x. 3 times 5x gives me a positive 15x, which combines to be a positive 9x. So that's check for us. We've got the positive 9x. And then lastly, do we have a minus 9 or negative 9? Well, a positive 3 times negative 3 gives me a negative 9, because a positive times negative is negative. So by expanding our brackets, we get what we started off with, so we know we factorized correctly. So in summary, remember, if it is a non-monic, you have to do 2 extra steps. Non-monic means that the a value or the coefficient of x squared is not equal to 1. You still write your a, b, c values. You still do your plus b times ac table like we did yesterday. You still write your brackety. But rather than just writing x, you will have to write 10x, because the coefficient of your x squared is 10. So whatever that coefficient is, you put that in. You also have to divide by that same coefficient. So that's the first extra step. You then put the two numbers into your brackets as usual. Your second extra step is then to factorize out as much as possible the numbers inside your brackets. Ideally, it should work out that your numbers, on the coefficients on top and whatever's on the bottom cancel out, because you don't want any denominators. You don't want anything on the bottom. So 5 times 2 is 10, which perfectly cancels out with the 10 on the bottom. So now whatever's left over are your brackets multiplied by itself, so that we have factorized the quadratic, because